Hey everybody, I thought I would go ahead and see if I could derive, oops, I don't want to be on the pen, there we go. Give me, yeah, that's the right thickness, thank you much. I wanted to derive this, and before I did that, I wanted to explain these two items. The first one here is the expected value of the x squared. So really, it's the mean of the x squared. So I add up all of the terms that have been squared, divide them by the number of numbers. And then this one over here is finding the mean of the x's and then squaring it. So it's just a different notation for that. Okay, so I'm going to do that by expanding the definition of sigma squared. And first thing I'm going to do is I'm going to take this and I'm going to FOIL it out. So what I would have if I FOILed it out is the sum from I equals 1 to n of x sub I squared over n minus the sum from I equals 1 to n of negative 2 mu. Okay. Excuse me. Yeah, negative 2 mu. This would be plus negative 2 mu over n. And then plus the sum from I equals 1 to n of mu squared over n. Now, let's see. You might not see where I got that from, but if I FOIL this, I get x sub I squared minus 2 mu, excuse me, I missed something there, x sub i's, and then plus, and so I got to insert that in a second here, mu squared. So I got to have x sub I here. Perfect. Okay. So now I'm going to take this, and of course this is all equal to sigma squared. All right. This right here, this first term, is this right here. It is the expected value of the x squared. So what I'm doing essentially is I'm adding up all of the x terms squared and dividing by the number of numbers. That is the mean of the x squareds. So I'm going to take this and I'm going to show you how that is equivalent to the expected value of x quantity squared. Okay, and in order to do that, I'm going to take negative 2 mu out in front. Okay, and take x sub I, leave it on the inside, and divide by n. Okay, so let's think about what we have here. This is negative 2 mu times mu again, right? That's the average of the x values. So really, essentially, this term right here in blue is negative 2 mu squared. All right, so now let's dissect this last piece a little bit. This is the sum of, this is mu squared times n divided by n. All right, so it's mu squared plus mu squared plus mu squared. How many times? Well, n times. And then I'm going to divide that by n. So what do I get? I get mu squared. So when you have negative 2 mu squared, plus mu squared, what happens is I get the average of the x squareds minus, how many? Well, 2 of them minus 1 of them gives me 1 mu squared. So a little proof there, but what I like to call this is a different way to look at the variance when you have some information missing. but you do know enough information to find that stuff. So something we'll see come up pretty often. And actually, I've got to make an example of it here that I'll go over in just a second. All right, so here's an exam question from a few years back, 6 marks. So the 6 marks should tell you, hey, this is attainable. So I'm going to go ahead and use the hint just slightly here, these 2 items, and I'm going to come back and explain what I did. All right, so as you can tell in the red pen there, I realized halfway through that I didn't need an N, I needed a 10 there, and I don't know how to use the eraser yet, so that's cool. I expanded this piece right here by foiling. So that gives me these following 3 items. Okay, so I can find said thing, right, what we're seeking here, by using some of the information given. Okay, so if the mean is 10, right, if the mean is 10, then the summation from I equals 1 to 10 of x sub I over 10 equals 10. So now what would that mean about this, right? Well, that would mean that we have multiplied both sides by 10. So this would equal 100. So I've got minus 24 times 100. That's just the sum of the x's. Right? This piece right here is 10 144s. Well, that's 1440. So all I really have to do here is do a little work on this, and I will have achieved what I'm looking for, which is looking for this summation, x of I minus 12 quantity squared. All right, so I'm going to do a little work, and then I'm going to subtract 2400, and then I'm going to add 1440. All right, so let's look at this piece down here. All right, so what is that? That's the sum of each of the terms squared. So let's look at how that fits into the bigger picture here. Well, we know that variance is equal to the expected value of the x squareds minus the expected value of x squared. Well, I know what the expected value of those x's are. That'd be 10. Right, that's the mean. And I know what the I know what the standard deviation is, right? The standard deviation is 3, so that makes the variance 9. So the expected value of all of the x squareds is going to be related to those 2 things, as proven on the previous page. So I can change this expression to the following. So think about this for a second. If I sum up, oops, I should have a square there. If I sum up all of the values squared and divide by 10, that gives me the expected value, or the average of the x squareds. So now all I need to do is solve for this, and I can plug it back in up above. So I'm going to add 100, so that's 109. That's equal to, I'm going to just call it this thing over 10. And I'm going to multiply by 10, so that tells me I'm going to get 1090, which is actually police code for a mullet. But anyways, so this thing up here is 1090. So the problem that I'm seeking to discover here, which is this, given limited information, is going to require me to do some math here. Let's combine these. That would be 960, I think. No, negative 960. Yeah, I think that's right. Negative 960, and I'm going to add it to this 1090, this mullet over here. I think that gives me 130. Check that out. That's pretty awesome. I can utilize just foiling and this cool variance and expected value equation to solve a 6-mark problem. Now that took me 5 minutes to explain. 6 marks should be about 8 minutes, maybe 9, depending, that you should allocate to that on the exam. So I hope you tried this without watching the video first, but hey, you know what? More power to you, whatever you got to do. Let's get it done, get that 4, and grow out a mullet. Have a great day.